In this video, we will watch Mercury as it revolves around Sun. We will also notice its motion as it rotates around its own axis. Mercury has a very interesting characteristic. The time it takes to rotate once about its axis is exactly 2/3 of the time it takes to revolve around Sun. In other words, by the time we see Mercury go around the Sun 2/3 of a revolution, the arrow shown here on Mercury will rotate one complete rotation. We are going to track this motion of Mercury and try to understand it. We will view Mercury as it travels 1/3 of a revolution around its orbit. And let's watch the orientation of the arrow. Right now, the arrow, which might represent an observer standing on Mercury, is directly pointed towards the Sun. This represents local noon for a person standing on the equator of Mercury. Mercury will now revolve 1/3 of a revolution around Sun. Notice that in that time, the arrow has gone from pointing up to now pointing down. So the arrow has rotated 1/2 of a rotation, or we could say Mercury has rotated 1/2 of a rotation. What time of day would this be? Well, for a person standing here, they would see Sun to their west. So it is afternoon. Yet 1/3 of a year has gone by. Let's go another 1/3 of a year. The arrow is now pointing directly upward, meaning the Mercury has rotated one complete rotation. The arrow started out pointing upward, and now it's pointing upward again. It's gone around one time. But notice where Sun is. If we were to draw a line across the horizon of Mercury here, that person would not see Sun right now. It is nighttime. So in 2/3 of a year, the Sun has basically set. Here's another 1/3 of a year. Mercury has now made one complete revolution in its orbit around Sun. What time of day is it for this person on Mercury? Originally, they were seeing local noon. They were seeing the Sun at local noon. Now, the person is faced directly away from the Sun. As a result, it is local midnight. In one complete year, it has gone from noon to midnight. That's only half a day. Let's follow again the motion for another year. Now the person is just about to see the sun rise. Now they see it rise, and they'll see the sun in the east. And now it's local noon again. It has taken 2 complete revolutions around Sun for the time to go from local noon to local noon again. Therefore, a solar day on Mercury, or what we would call a Mercurian day, is equal to 2 years, because it takes Mercury 2 years in order for it to rotate once with respect to the Sun. As a result, Mercury undergoes extreme temperature changes. During the daytime, which it gets for roughly a year, it'll see the Sun, or that side would see the Sun. But for a whole year, the Sun will not rise for a person on Mercury. So that part of Mercury will have no sunlight for an entire year, and it gets very cold. Let's watch it again. In 1 year, it's gone from noon to midnight. And in the next year, it's local noon again. So it takes 2 years for it to be local noon and then local noon again for an observer on Mercury. 1 Mercurian day is equal to 2 Mercurian years.